is what? What's the molar mass? It's in the name. Mass of 1 mole, right? That's why it's called molar mass. It's the mass of 1 mole. So we're going to do the molar mass. Finish this off. We have an aluminum. We have an aluminum atom. How many nitrogen atoms do we have in this molecule? 3, because we have 3 NO3 molecules. This is like math, right? The 3 goes to the N. So we have nitrogen. We have 3 of them. How many oxygens do we have? We have 9. 3 sets of 3. Okay. What's the molar mass of aluminum from your periodic table? Sorry? 57? 27. Okay. 27 grams per mole, right? So aluminum is 27 grams per mole. What's the molar mass of nitrogen? 14? 14.0? 14.0, which grams per mole, but we have 3 of them, so we have to multiply that by 3. What's 3 times 14? 30, 12, 42? You really taking a calculator?
14 times 3, 42. Just if you didn't know.
42 grams per mole. And oxygen has a mass of 16, and we have 9 of them, so it's 9. These are all to 2 sig or 3 sig figs. 0.0. 0.0. What's 9 times 16? 10 times 9 is 60, or 90 times 6, 54, 144.
I said it quicker. I win.
144.0 grams per mole. Okay, so how do I get the molar mass? Add them all up. 27 plus 42 plus 144 should give us 213.0 grams per mole. Is that okay? Yep. Does that just look like you had your hand up? Okay. All right. So before we move on, just to make sure that we understand this, I would like you to grab a Hebden. Do question 6A to H. It'll be very quick, and then we're going to move on with some more unit conversions. Okay. So I'll give you about 10 minutes to do those questions. 10 minutes. Okay. So moles are good because it gives you a number that isn't like super tiny or super large. It's a workable number. The problem is you don't measure out moles, right? We use scales to measure mass. So we have to be able to convert how many moles you have or want to a mass, all right? And this is why we were doing molar mass. So, what's the mass of 1 mole of sodium chloride, NaCl? What's the mass of sodium? 23? 23, just 23? 23.0? Is that it? What's the mass of chlorine? 35.5. You add them together, you get so the molar mass of sodium chloride is 58.5 grams per mole. If you have 2 moles of it, how much should it weigh? That's the mass of 1 mole. So if you have 2 moles, just double it, right? Multiply it by 2. If you did you can do the unit conversion. If it's, you don't have to, but 58.5 grams per mole, and you have 2 moles, multiply them together, and you get 117.0 grams. So obviously it just scales up, right? It doubles if you have 2 moles. So our conversion factors of molar mass are just like it was for Avogadro's number. You can write it as molar mass. I'll put it in brackets, which is grams per mole, or 1 mole is, if I put mm, are we okay with that for molar mass? That is the actual notation. Mm, which is in grams. So just like we did with Avogadro's number, we can flip them upside down depending on what we want to cancel, right? In this one, I had it as grams per mole. I was using this one because I want the moles to cancel. All right? Okay, so the questions are going to start to look like this. So how many moles of N2 are there in 50 grams of N2? So they give you 50 grams, okay? 50.0 grams of N2. What do I want in the next box? What do I want in the bottom of the next box? Grams or moles? Grams, right? Because I want the grams to cancel. They want the answer in moles. So we need to figure out the molar mass of N2. Okay? What's the molar mass of nitrogen? 14. Is it 14? 14.0. Molar mass of nitrogen is 14.0 grams per mole. I have 2 nitrogens, so I multiply it by 2, which gives me that's the molar mass, 28 grams of N2. Grams per mole, sorry. Okay. So to cancel this grams, I write 28.0 grams of N2 is 1 mole of N2. So we're using this one, right? We flipped it upside down because I want grams to cancel. So now grams cancels. 50 divided by 28. 1.79. Okay, perfect. Thank you. 1.785, blah, 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 right? How many sig figs are we supposed to have? 1, 2, 3, 1, 2, 3, 3 sig figs. Round it. Remember, look, I don't, on the test, I didn't care if you put 1.79, but what's that? Technically, we were supposed to, remember I told you about rounding to the even? Remember that? Did I say that in class? When you have a 5, technically you're supposed to round so that this number is even. Okay? Because then it all averages out. All right? So if it's a 5 and this is even, you would write 1.78. We'll just round it to 1.79. I actually don't, doesn't matter to me. But in practice, out there, being a chemist, you would round to the even number. Okay, if it's a 5. Now it's a subtle rule. It's because you have 1 to 4, and then you have 6 to 10. 5 is sitting in the middle. So if you round some to an even, you average out so that they're not all being rounded up. All right, but we can leave it as 1.79 moles of N2. What was your question?
Is that 1 mole and N2 over 28.0 grams N2
Yeah.
the conversion factor? Like,
Yeah.
It's a fix?
Yeah, because we're accepting like the. Are you talking about the 1?
Yeah.
The 1, yeah. It's like we know like that's a counting thing, right? So it'd be 1. It's like don't use sig figs for that. Okay. How many moles of Ca calcium hydroxide are there in 89.6 grams of calcium hydroxide? What's the first step in almost every one of these? Well, it is the first step in all these questions. What do we need to figure out? Molar mass. It's almost the first step in every question that you're going to see. Well, not every question, but a lot of them. So we got to do the molar mass. Calcium, oxygen, and hydrogen. I'll wait for you to calculate the molar mass of calcium hydroxide.
You know what I do for this one? Instead of like specifically writing out each one of those, like if we have
Yes.
a polyatomic ion,
16 and plus 1 is 17 times 2 is 34. I don't even know what calcium weighs. What is the mass of calcium? Sorry, what's the mass of calcium? 40.1.
or 0 decimal
What's oxygen? 16.
0.
What's hydrogen?
1. Why are you asking me? You just did the.
I know hydrogen's 1.
I know, but like you asked me what oxygen was after doing that.
I know, and then 72, 74.1.
That's what I got. No.
You're adding, so it's decimals.
You just didn't put a
Right.
decimal in 16.
I know. So we should get 74.1 grams, correct? For the molar mass. It is because we're adding, remember, it's decimals that we look at. And because all of these are to one decimal place, we keep the one decimal place. So 74.1 grams per mole is our molar mass of calcium hydroxide. So we have 89.6 grams of calcium hydroxide. And what do I want? Do I want grams in the bottom or the top? Bottom. So 74.1 grams of calcium hydroxide is 1 mole of calcium hydroxide. So you divide them and you get, what do we get? 1.209, which rounds to, right? The 9 will kick it up. So 1.21 moles of calcium hydroxide. Okay, so that's going from mole or from grams to moles. Now we got to go the other way. All right. What is the mass in grams of 1.36? Because this is a type of question you would get. You'd say, oh, I need this many moles of this. You have to weigh it out. Although CO2 is a gas, so it's a little tricky to weigh it, but we'll pretend. All right. The mass in grams of 1.36 times 10 to the minus 3 moles of CO2. So, molar mass. What does carbon weigh? 12.0. There's a lot that you use over and over again, so you just get to know them. 12.0 grams per mole. What is oxygen? 16.0, but we have 2 of them. So 12 and 32 gives me 44.0 grams per mole. There's your molar mass. They give us 1.36 grams, or 1.36 times 10 to the minus 3 moles of CO2. Okay. What do I want in the bottom of the next box? What units? Moles, right? So I can use this as is. I can write 44.0 grams of CO2 is 1 mole of CO2. Cancels, cancels. I have no idea what that is. Should really bring a calculator with me. Point 0.05984. How many sig figs do we need? 3. So it should be 0.598 grams. Right? The 4 doesn't do anything. Does that make sense? All right, last question for the day, peoples. For 3 days. Long weekend. And then I think it's 3 short weeks in a row.
Is it actually?
Yeah, because then next weekend's Thanksgiving, and then the weekend after, or the week after that, there's a pro D on the Friday. So, and then it's like the end of October. School's almost over. All right. What is the mass in milligrams and 2.4 moles of SO3? Notice that they highlighted the word milligrams. Everything we've been doing is in grams. So we're going to have to add an extra unit conversion, but we'll do that at the end. What's the first step? Molar mass. It's almost like every time. All right. Molar mass. Do it over here. Sulfur. Oxygen is 16 times 3, 30, 18, 48.0. Sulfur 32. 32.1.
How's it already 10 a.m.?
Because time flies when you're having fun. 60.1. Molar mass 60.1. Is that right?
You're 20 off.
Because 4 and 3 is 70. I'm good at math. I should go teach math. 70.1. No, 80.1. There we go. 80.1. Did I get it right the third time?
Yes.
All right. We have 2.4 moles. So 2.4 moles of SO3. What unit do I want in the next box? Moles or grams? Moles. In the bottom one. Sorry, that's what I'm asking. So I want 1 mole of SO3 is 80.1 grams of SO3. So we know those are going bye-bye. Now I have my answer in grams, correct? Is that what we want our answer to be in? No, we want it in milligrams. Does anybody remember the conversion factor of milligrams and grams? Milli. So you're right too. So it's 1,000 milligrams for one gram. Okay, that's what milli means, or 10 to the 3, same thing. So I want grams to cancel, so I put grams down here. I put 1,000 milligrams there. And then you just multiply them across. How many sig figs should our answer have? 2. Look at this. You're this awesome class. I have no idea what the answer is.
190,000.
What?
190,000.
190,000? That's a lot.
Am I right?
So we get 192,240 milligrams. Clearly, that has got way too many sig figs. We need to have 2 sig figs. So you take the first 2, those ones. You look at the next number, which is a 2. Does that do anything? No. So we should have 190,000 milligrams. If you don't like that, the way that I find a little easier is to put it in scientific notation, but you don't have to. If I wrote this in scientific notation, that's 1.92240 times 10 to the 1, 2, 3, 4, 5. And then if I want 2 sig figs, I'm just taking the 1.9, and I get 1.9 times 10 to the 5. That's the same as that. Okay? All right. You can do, what does it say? There are some questions from Hebden. You can take a picture of the book if you want. There's only 10 minutes of class left. I was going to say Monday. On Tuesday, we will do an activity. I don't think it'll take the whole class. Wednesday, we'll do an activity, but we'll also continue with this stuff. We're going to move into a little bit of empirical formula and then in dilutions and blah, 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 blah. But you should be able to do these questions. So I strongly recommend that you practice using those questions. Have a good weekend.
You think we're gonna have a good weekend with no Mr. Bolden?
Oh my gosh.
Oh my gosh. They will. They're like, thank God. I don't know.
Yeah, there's like I've heard rumors of a huge group chat with like 200 people, and all they do is just hate on Mr. Bolden.
Hate on me?
Yeah. It's just all your morning classes.
It's like, we hate Baldwin.
Yeah.
It's like the whole school, really.
That's what the group chat's called. Mr. Bolden, if you were the dean of a university and somebody called
Dean?
yeah,
You should listen to this. It's literally you.
I can't.
It's literally you.
I literally can't because I don't have YouTube.
It's also on YouTube.
I don't have YouTube for now.
You don't need
Well, I need to be able to listen on more.
Listen to it. Stop making excuses.
I will get these back to you ASAP, Mr. Bolden.
I don't need them. I was more that one question that I was. Oh, hang on.
We will revolutionize